I'm going home, huh?
Yeah, I know. This isn't gonna cost you any time. It's a chance for the people on Earth.
Talk to me.
Gargantua is an older spinning black hole. It's what we call a gentle singularity.
Gentle.
They're hardly gentle. The tidal gravity is so quick that something crossing the horizon fast might survive. A probe
Able to escape the black hole after passing the event horizon, and in the movie he does pass the event horizon. The event horizon is the boundary of the black hole, but it can't be gone through. It just cannot be escaped because a really high velocity is needed to escape, and light can't even escape, and light has a velocity of 2.9979 times 10 to the power of 10 meters per second, and no human can reach that, so no one should be able to escape the black hole. As you go down the black hole and get closer to the singularity, which is the center of the black hole, the gravitational pull starts to increase, and when you're outside of the black hole, it appears as a personal thing is falling slower and slower and slower, and the light is having a harder and harder time coming out since the gravitational pull is pulling it inwards. So once it passes the event horizon, no light is exited from the black hole. Therefore, we have no signal and have no idea what has passed the black hole.
It's all black. Charles, do you read me? It's all blackness.
Okay.
Screens. Any interference. Losing control of the stick. Got flashes. Flashes of light and blackness.
When talking about the gravitational pull while going into a black hole, tidal force is the difference between the gravitational pull of your head and your feet. So if you go into the black hole head first, and your head will have a higher tidal force than your feet will. So then your head will stretch at a faster rate than your feet will. You'll stretch so much that eventually at one point you'll split in half, and each half will keep splitting in half and half and half until you're basically like atom-sized. As you get closer and closer to the singularity, which is the center of the black hole, you will also squeeze because of the distance between the radial lines is getting smaller and smaller. So it is impossible for him to not spaghettify going into the black hole because of the extreme gravitational pull. And he also went through a smaller black hole, which is like more deadly and more gravitational pull than a bigger one, since it sucks in more light into one space. So.
Everybody ready to say goodbye to our solar system? To our galaxy. Here we go.
The special theory of relativity states that the faster something travels, the more time stops until it reaches the speed of light, which is when point time stops altogether. And according to the speed formula, which is distance over time, if time stops or equals to 0, then speed stops altogether. So, because of the special theory of relativity and the speed formula, it is impossible to travel faster than light.
No.
No! I commanded a 50-50 case, you're gonna kill yourself! Those are the best odds I've had in years.
It's not possible to stay conscious for 45 seconds on another planet without oxygen supply. Respiration is controlled by the brainstem, which unconsciously allows humans to breathe. When oxygen levels begin to drop, hypoxemia occurs, and we begin to lose consciousness as the brainstem begins to lose control. Without oxygen reaching our brain, our sensitive brain cells begin to die, which leads to our unconsciousness after about 30 seconds.
The planet is much closer to Gargantua than we thought.
Gargantua. It's what we're calling the black hole. Miller's and Dr. Mann's planets both orbit it.
And Miller's is on the horizon?
Or is a basketball around a hoop? Landing there takes us dangerously close, and a black hole that big has a huge gravitational pull.
The planet cannot exist because of Rossum. Rossum is the closest distance a planet can approach a larger body, which is a black hole, without tidal forces ripping apart the planet. You can calculate the Roche limit with the equation Roche limit is equal to density of the black hole over density of the planet to the power of 1/3 times 2.44 times the radius of the black hole. You substitute and simplify, and you get the Roche limit to be 3,646 miles. Then you compare that to the actual distance, which is 3,185. You can find the Roche limit is greater than the actual distance. So this planet cannot exist because the tidal force, without the tidal forces overcoming the internal gravity of the planet and ripping apart the planet.
Gravity's punishing.
Been floating through space too long?
130% Earth gravity. Wreckage. Where's the rest?
Where's the mountains?
Those aren't mountains. They're waves.
Fran Doyle, back to the Ranger now.
The particles of the water move in circular motions in a clockwise motion as waves pass by. The circular motion gets lower deeper below the wave. When the depth is length divided by 9, the radius of the motion is about half of the surface, and the circular motion stops when the depth is equal to the length divided by 2. The energy of the wave is stored in the top part of the wave. When the water depth decreases to half the wavelength, the wave becomes a shallow water wave. As the water gets shallower, the gentle slope approaching makes the bottom part of the wave to drag, causing the top of the wave to fall, as it only falls because the dragging makes the top of the wave overtake the bottom of the wave.